So, just before I go into the next couple of limits, which are all trigonometric, I'm just going to remind you of that PowerPoint presentation or that slides presentation which I put in the group on the classroom last week. And towards the end of that, when we were talking about limits, there were two trigonometric limits that we investigated. And that was the limit when x tends to 0 of the sine of ax over ax, which is equals to 1. And the second one was the limit when x tends to 0 of the tan of ax over ax, which is also equals to 1. Now, I just want to emphasize that in this case, what is very, very important that we keep in mind is the fact that the argument of the sine and the tan has to be exactly the same as the denominator in both cases. Okay, and that is essential for me to be able to understand this limit. So I'm going to go to the first limit here, and I'm going to say, well, if I've got this limit here, what I could do, just to try and find something, get something out that I could work with, I will say this is the limit when x tends to 0 of, and I could divide that into 1 over x times the sine of x over x. Now, according to what we've seen here now, I could say that this limit here has a value of 1. However, because I've got a 1 over 0 over here, because remember, as x tends to 0, that will become undefined if I was to substitute by 0. So this one is 1, but that is still undefined. Therefore, there's nothing else I can do here, so I can conclude that this limit is either undefined, okay, or in other words, you could also say that this function does not converge. In other words, the function doesn't converge to a value. As a matter of fact, it does diverge to a completely different value. Okay, so moving on to the next trigonometric limit. So here we have the limit when x tends to 0 of 1 over the cot of 3x over 4x. Okay, so what I could do in this case is I can say, so in this case I can just write it as, remember that the tan and the cot are the reciprocal of one another in terms of trigonometry. So I could write the 1 over the cot of 3x, or I could say that 1 over the cot of 3a is the same as the tan of 3a. Okay, so once I've got that, I can now go on and say, so I could then rewrite this limit and say this is the limit when x tends to 0 of the tan of 3a over 4a, or 4x, let's just call it, let's just have the same variables, 4x. Now, going back to last week's lesson, if I look at this limit over here, okay, remember, if these arguments are equal, then I can say that the limit when x tends to 0 is 1. What is the problem that we have here is that the argument here is 3x, where the denominator here is 4x. So how can I change that? Okay, what I would do here is I will multiply both sides by 3 over 3. So in other words, multiply numerator and denominator by 3 over 3. So multiplying by 1, literally. When we do that, what we're going to encounter is that now I can say, I can replace these 4 and I take this 3 to the front. So this is going to become 3 over 4. Remember, this is a product, so I could bring that coefficient to the front. So 3 over 4 times the tan of 3x. Please note that I haven't changed anything there. And all I did was, in the place of this 4, I put the 3x. Now, according to what I know from limit when x tends to 0, I could say that the tan of ax over ax is equals to 1. So 3x and 3x, that means that these tends to be 1, and 3/4 times 1 is equals to 3/4. So the limit when x tends to 0 of this expression is equals to 3 over 4. Okay? Right. The last of the three trigonometric limits. So here we have the limit when x tends to pi. Remember, pi is equivalent to 180 in the conversion. But anyway, we're not going to consider that for the moment. The limit when x tends to pi of the cos of x over x minus 2. Now, If you were to substitute the value of x by pi in this case, you're not going to end up with anything that is undefined. So this is a question that has a solution. So if I was to substitute, I will end up with something like this. So this will be similar to something like the cos of pi, because remember that x tends to pi, over pi minus pi over 2. And if I was to calculate that out, remember that pi is 180, so if I go and draw the function cos, remember more roughly at 180 degrees, which is equivalent to pi, okay, the function has a value of -1. So the cos of pi is equals to -1, and pi minus pi over 2 is equals to pi over 2, and when you divide that fraction, that gives you -2 over pi. Okay, with this, it's just the basics of limits that you have to know, and these are the answers to the worksheet from last week.